Is one screw really enough? It's well known that loose connections on meter tails can cause fires. It's one of the big reasons the UK shifted from plastic to metal consumer units. But here's the question. How did we end up in a situation where equipment that had been installed for years suddenly became a headline fire risk? Part of the answer is hidden inside the main switch. Go back a bit and the terminals look like this, a solid block of brass and crucially 2 separate screws clamping the conductor.
Have you ever installed a board like this in a new installation like I have? If so, leave your thoughts in the comments.
Because today, a lot of main switches are DIN rail mounted and many move to a single screw and a different style of terminal, often a cage clamp, where the conductor is held by the clamp rather than a screw biting into it. Both designs have advantages. A cage clamp can reduce strand damage. A screw clamp gives you a very direct mechanical grip, but over tighten it and you can deform the strands. The real issue is what happens in the real world when tails are disturbed, and they started being disturbed a lot more. 2 big moments. First, this issue really got flagged during the rollout of smart meters because the meter tails often got moved or flexed during meter exchanges. That's fundamentally a meter fitting disturbance issue. But now it's become even more relevant because more and more electricians are working in and around meter boxes too, adding kit that needs the tail splitting or extending for things like EV chargers, solar PV and heat pumps. And if those tails aren't properly clipped and supported, it doesn't take much pulling, twisting or knocking for movement to find its way right back to the termination. So in this video, we're going to test a simple question. Are 2 screws actually better than 1? And did that change contribute to loose tails and overheating? And we'll finish with what the regulations eventually tightened up, supporting and securing meter tails properly because terminal design is only half the story. Now, on the metering side of things, the stuff we're not allowed to touch because it's sealed, here's the weird part. A lot of it still uses the old school 2-screw approach. Terminal blocks, many meter terminals, and service heads are still typically brass screw clamps, often with 2 screws. But of course, as electricians, we shouldn't be accessing that equipment and we're not supposed to remove seals on DNO or metering equipment. So if you need an isolator fitted or metering equipment moved and you want to stay safe and legal, one option is using a safe isolation provider, a SIP. We actually saw A Cool Electrical, a registered SIP, in action on a recent project where the electrician needed an isolator installed. We'll include a link to them in the description. And while we're here, it's worth remembering that service heads and older metering equipment come with real risks, especially on older properties where equipment can be decades old, sometimes even approaching a century. That's why we've included a section in our free training module called Unsafe Isolation, showing what to look for and the safety equipment and precautions needed when you're working anywhere near service equipment. Now let's get back to the point and actually compare how secure these terminals really are. First, we're going to look at how easy it is to remove a cable from a single screw cage clamp like the type you'll find on many 100 amp isolators. Then we'll compare that to this 100 amp isolator from Whitecliff, which uses 2 screws. What's interesting here is that the terminal design is still based around a cage clamp, but with 2 separate cage clamps in each terminal rather than just 1. For contrast, we'll also test a single screw traditional style brass terminal found in this Whitecliff switch fuse, the sort of connection you'll often see installed inside meter boxes. To keep things consistent, all tests will use the same 25 square millimeters meter tails. For the cage clamp tests, we'll use both 19 core and 7 core variants. The terminals that do have a torque setting will be tightened exactly to the manufacturer's recommended torque. The single screw brass terminal doesn't have a torque setting, so we're tightening that squeaky tight. And yes, you can roast me in the comments. Now let's do the waggle test. We're going to move the tail side to side and see how easy it is to work the conductor loose from the terminal. And you can see on the single screw cage clamp, just a few movements and the terminal starts to loosen up. Now compare that with the double screw terminal, and you can see it's almost impossible to get that terminal to loosen in the same way. It's a similar story with the single screw brass terminal as well. And interestingly, it doesn't make much difference whether we use the 7 strand or the 19 core 25 square millimeters meter tail. The behavior is broadly the same.
It's no secret that I love a torque screwdriver. However, let's put it into context for people who don't believe it's worth doing it to the required torque setting as per manufacturer's instructions. Just think about that aeroplane you're jetting off for a lovely 2-week summer holiday with your family, and you look down at the wheel and think to yourself, I wonder if the person that bolted those tyres on used their engineering judgment and their torque calibrated arm, or they used the correct equipment.
So just to keep those folks happy, let's repeat the test on the single screw cage clamp, but this time we'll go beyond the torque setting and take it to squeaky tight. Of course, the regulations don't mention torque settings specifically. They simply state that manufacturer's instructions should be taken into account. But you'll notice these days that more and more consumer units and protective devices are actually marked with a torque value, and that's there for a reason. And if you're interested including what really happens when connections are over-tightened or under-tightened. We made a separate video exploring exactly that with insurance industry investigator Dr. Robert Weller. In that video, you'll learn why copper is really just like a jelly baby, and once you've seen it, you won't forget it. It's well worth watching after this one, and we'll link it in the description. Now, when it comes to torque screwdrivers, our go-to for many years has been this one from Weha. The main reason is its wide torque range, and with the slim Vario system, you get a huge choice of bits, including hex and Torx, which are appearing on more and more equipment these days. Again, we'll pop a link in the description if you want to know more. Right, so how do the wiring regulations actually deal with this problem? If we turn to BS 7671, regulation 522.8.5 states, every cable or conductor should be supported in such a way that it is not exposed to undue mechanical strain, and so that there is no appreciable mechanical strain on the terminations of the conductors, account being taken of mechanical strain imposed by the supported weight of the cable or conductor itself. And there's also an additional note that makes it very clear what they're getting at. Consumer unit tails are included in the requirements of this regulation. We take that note as a big underline that this is a known problem.
And before you jump into the comments, it won't be different in the tangerine version either.
So how do you deal with it? Well, we've demonstrated that double screw devices are more robust than a single screw cage clamp, especially when you're working with meter tails in the confined space of a meter box where cables can easily get knocked. In consumer units, we're also seeing more manufacturers moving over to double screw main switches, and where you've got a single screw device, one approach is to use an additional cable clamp assembly or a meter tail gland so the tails are properly supported before they ever get a chance to move. Or in existing installations, it can be as simple and as important as making sure the tails leaving the consumer unit are properly clipped or supported, adding additional fixings where required to prevent movement in the first place. But here's a word of warning. This isn't just a meter tails issue. A lot of outgoing circuits use larger conductors. Think 10 square millimeters on an electric shower, and a 10 square millimeter conductor into an RCBO, MCB or main switch has the same basic risk: movement, relaxation, and a connection that can work loose. So if you're working inside a distribution board, adding a new circuit, or even just dressing cables to be Instagram tidy, it's always worth checking that existing connections are still tight and haven't been loosened by the work you've just done. Let us know in the comments any loose connection challenges you found on site and what you did to rectify them, because of course lots of us are now fitting EV chargers and other kit, which often means altering the electrical arrangement in the customer's meter box, and that's an area that comes with its own challenges. We actually think there's a better way of dealing with this, and we made a video discussing our ideas for a better solution. It would be great if you could check that out and let us know what you think.